Welcome to Soil Smarts Video 5, Unearthing a Better Approach. DTSC has created this educational series about the soil cleanup of chemicals to local background levels at NASA and DOE areas of the Santa Susana Field Laboratory. These videos are part of a package of materials to help inform the public about the challenges related to ensuring completion of cleanups. You can access the entire series on our website. DTSC is committed to a soil cleanup that is consistent with local background. We are unwavering in this commitment. In this video, we will be discussing an approach that DTSC is proposing to determine when the cleanup to local background has been achieved at Santa Susana Field Laboratory. A new approach is needed to address the technical issues discussed in the companion videos within this learning series. We recommend that you watch those other videos first so that you may better understand why we are proposing a new approach. Before we jump into the new proposal, let's talk about why it is needed. The not-to-exceed approach fails to identify background soils. As shown on the map, when DTSC applied the approach to our background reference areas, 54% of the soils failed. This is what's known as a false positive error. False positives are common when using simple comparisons, which rely on a single line of evidence. US EPA recommends the use of multiple lines of evidence as a best practice in environmental cleanups. So what does this term, multiple lines of evidence, mean? Basically, it means that we will be using different types of proof to support an idea. The approach makes an argument stronger and more reliable than using a single piece of information. DTSC is proposing a multiple lines of evidence approach for determining when the Santa Susana Field Laboratory soils have been cleaned to local background levels. There are 5 main lines of evidence proposed. We have 3 tiers for categorizing these different lines of evidence. Green is used to indicate the line of evidence is supporting that the sample is consistent with local background. Orange is a neutral line of evidence, and we should consider other lines of evidence. And red means that that line of evidence has failed, and we think that remediation is required for that sample. Our current recommendation is that if we have 3 supportive lines of evidence, then that sample would be considered consistent with local background levels and would not require further soil removal. Each line of evidence answers a question. The first line of evidence addresses the issues with the lookup table values that are discussed in detail in Soil Smarts video number 2. We asked 2 questions in this line of evidence. The first question asks, is the detection consistent with local background? The second question asks, is the method reporting limit for the MRL-based lookup tables reliably achievable? We answer the first question by comparing any chemical that is detected above its lookup table value to the full range of detections from the Chemical Background Reference Study. So let's look at an example. Here, we have a scatter plot of the sampling results for a single chemical as measured in the DTSC Chemical Background Study soil samples. Each dot represents a single sample, and the position of the dot on the y-axis, the vertical line on the left side of the figure, represents the concentration in micrograms per kilogram of the chemical. The blue squares are detections, and the orange dots are non-detected values shown at the detection limit for the sample. The lookup table values for this chemical is shown by the blue line. So in this example from the background study, we'd be comparing a detection in the NASA and DOE soils, this maximum detection from the Chemical Background Study. If the detection in the site soils was below this value, that would be a supporting line of evidence that the concentration is consistent with local background levels. In the second question in the first line of evidence, we ask, is the method reporting limit for the MRL-based lookup table reliably achievable? To answer the second question, DTSC recently approved work plans from the responsible parties to evaluate current laboratory capabilities. It is important that MRL-based lookup tables are able to be reliably met by laboratories. The results of this study are expected in late 2024. In the second line of evidence, we are asking the question, is the chemical that was detected above the lookup table value below its health protective screening level, assuming residential land use? If the answer is yes, that is considered a supporting line of evidence. In those first 2 steps, we are looking at individual chemicals above their lookup table values. In the next two steps, we are looking at everything detected in a single sample. In step 3, we are asking, is the cumulative risk below the DTSC point of departure for residential land use? This means that we calculate the risk and hazard associated with every chemical detection in a sample, and we add them all together to get a cumulative risk and non-cancer hazard. Again, we are comparing that to the point of departure. In most sites in California, this would mean there would be unrestricted land use. When we evaluate a site for residential use, we assume that people are exposed for 350 days per year for 26 years, for a total ingestion of 7.5 cups of soil at the evaluated concentration. In typical residential scenarios, we are averaging soil concentrations across the entire residence. For the background cleanup at SSFL, we are doing these evaluations on a sample-by-sample basis. This is incredibly conservative, as this would be 7.5 cups of soil ingested at a single location, which is well above a reasonable estimate. So, if the cumulative risk is below the point of departure for residential use, that would be a supporting line of evidence that no soil removal is needed at that sample location. In the final line of evidence, we are asking the question, is the cumulative risk from all chemical detections in the sample equal or less than the risk at the related lookup table values? Remember, the cumulative risk is when we total the risk associated with every chemical detected in a sample to get a single risk value. But now, we will also look at that same set of chemicals that were detected in the sample and calculate the cumulative risk and hazard at the lookup table value for each chemical, and then we will take a ratio between the two. If the ratio is 10 or above, further soil removal would be required. This sample would not be consistent with local background, as the risks are higher than the related lookup table values. If the ratio is equal or less than 1, the cumulative risk for our sample is below the cumulative risk for the same chemicals at their lookup table values. This is a supporting line of evidence because the risk is below that associated with local background levels. So let's review. The 5 main lines of evidence answer the following questions for each soil sample collected at SSFL. Is the detection consistent with local background? Is the reporting limit achievable by laboratories? Is the detection below health protective screening levels for residential land use? Is the cumulative risk of the samples below the point of departure? Is the cumulative risk from all chemical detections in the sample equal or less than the risk of the related lookup table values? So, is the multiple lines of evidence a risk-based approach? No. This is still a cleanup to background. Risk is used as a tool to limit unnecessary soil removal and the destruction of habitat. Our evaluation is still on a sample-by-sample basis. It does not use area averaging. It just uses risk as a line of evidence to help us address those false positive issues. This can be seen when we apply the multiple lines of evidence approach to the chemical background reference areas, and it correctly identifies all the samples as consistent with local background. The workshop presentation that brings all of these concepts together is available on our website if you'd like to learn more. Additionally, we recommend you review the companion Soil Smarts fact sheet number 5, Unearthing a Better Approach, and the associated frequently asked questions. It is very important to note this is a proposed approach, but no decisions have been made. We want the public to weigh in on this proposal. We want to hear your concerns and your ideas. Please submit your comments through our new Stream tool. Thank you for watching this video.